Okay, so welcome back, and we are in Chapter 1, Section 4, Writing Equations and Inequalities today. This begins on page 21. So we're getting into equations. Now the question is, what is an equation? And we have talked about that the last couple of days. And so who can give us a definition in the fewest possible words for equation? The definition is?
It's
Two expressions that are set equal. That's an equation. Okay, I'm not writing it down. You take it down yourself. Two expressions that are set equal. So, how's an inequality different than an equation? Rather than having two expressions that are set equal, with an inequality, we have two expressions that are, Jake? Not equal. So what type of sign do we use if two expressions are not equal? Well, greater than and less than. And then we also have less than or equal to and greater than or equal to. So we have four possible signs that compare two expressions that are not always equal. Okay, so write down your definition for that. Okay, so we have this thing called an open sentence. And an open sentence means it's open to infinite possibilities. Often it's open to infinite possibilities. And this is algebra. So an open sentence might be something like x plus, give me a number.
200.
3 equals, let's say y.
Wow.
X plus 3 equals y. So that's open to infinite possibilities. I mean, if I tell you right now that x is 1, then y would equal 4. But if I tell you that x is 100, now y equals 130. You see how we could just come up with infinite pairs of numbers that make this true. So this sentence has two algebraic expressions. Do you see the variable on both sides? Two different algebraic expressions that are set equal. So it's an open sentence. The definition is this: a statement that contains two algebraic expressions and a symbol that compares them. So I guess we're not limited to equations. We could also use an inequality symbol between these two algebraic expressions. Let's try writing an equation or an inequality for this statement. The quotient of a number p and 12 is at least 30. I don't know how you're doing it if you're not turned and facing this way with a pencil in your hand. And that was recorded. Yes, you need to write down the statement because this will be useless to study from if you don't have the statement. Now, in your assignment today, you don't have to. If there's a statement, you can translate on your page, okay? I like to look for the dividing line between the two expressions. So who can find the word or phrase that's the dividing line between the two expressions here? And Stuart.
At least.
So, and the word is included there too. This whole thing is like the dividing line. Is at least. Will this be an equation or an inequality? Inequality. Is at least is not an equal sign. Is an equal sign. If that just said the quotient of a number p and 12 is 30, I have an equal sign where is, right? But this is some kind of an inequality sign. And on one side I have this, the left set part of the sentence. On the right side I have just what number? I have 30. So there's 30 over here, and then there's this whole quotient of a number p and 12. How do we write that? The quotient of a number p and 12. Brian? Good, exactly as it says. P divided by 12. So the quotient of a number p and 12 is at least. So if it is at least, could it be equal to 30?
Yes.
So we have that equal part of the inequality then. Now, if this left side is at least 30, could it be less than 30?
No.
Could this side be less than 30? Should it be greater than or equal to 30?
Yes.
Yes, so that's how we logically find the correct sign. If you are at least, then you could be greater than. This side could be greater than 30. So you may be greater than or equal to if you are at least. Okay, let's try checking solutions. So, what is a solution? If I have a basic statement, x plus 2 equals 7, what is the solution for this statement? Cool. 5. And why is that the solution? Okay, but there are a lot of questions I could ask, and not all questions give me a solution for an answer, amazingly enough. So what does it mean if it's a solution? And 5 is a solution, you're right. So what is this definition, Teddy?
It kind of just puts it all together.
Something that puts things all together. Sounds like a Lego builder. Is a Lego builder a solution? Aiden.
It's like a proven transfer.
So isn't it a value that we could substitute? So a value we can substitute for the variable that does what to that statement? Makes it true, and that's the definition. So a value when substituted makes a statement true. So you are now asked to check whether a given value is a solution for some math statement. So in number 1, we have a statement 6r plus 1 equals 25. And now the question is, when r equals 4, is that statement true? So is 4 a solution? R equals 4. Is that a solution to this statement?
Yes.
And thumbs up if you think it is. And thumbs up if you think it's not. So most people think it is. And so how did you determine that it was a solution then? Well, okay, so he's actually substituting. 6 times 4 plus 1, he's checking it out. He's saying, does that equal 25 in his mind? And he did it, mental math. 24 plus 1 is 25. So yes, 25 does equal 25. So yes, this is a solution. So that's one question you'll be asked today. Just to test whether a given value is a solution. So go ahead and test these and pause the video, come back and check when you have decided. So we found number 2, 5 is a solution, and number 3, 6 is not a solution for that one. Okay, it might be a solution in some other statement, but not in this statement. Okay? Yes, 1.5, using a problem-solving plan. So this is the second topic today. It begins on page 28. And we simply are doing a quick review of some formulas that you have used. And you will face some real-world topics and use orders of operation, variable expressions, the things we've been talking about, you're going to use in solving some problems. So with formulas, we always have more than one variable. It's an equation relating two or more variables. And you have then an open sentence where there are often infinite possibilities, and you might know one of the unknowns, you might substitute, and then you'll find an output, right? We have 4 special formulas that you have used that you may also need to use today. So we're just doing a quick review of these 4. So for your reference, so temperature. This is a conversion formula that we can use to move from Celsius to Fahrenheit. It could also be used to go from Fahrenheit to Celsius. Actually, right now, as it's written, if you know a temperature in Fahrenheit, you could then plug it in and out pops the Celsius, right? You can manipulate this formula, change it up so that the F is isolated, and then you could substitute a Celsius temperature and get your Fahrenheit out. We operate mostly in Fahrenheit in our everyday world when we're talking about temperature. But in the medical world now, they're pretty much moving to Celsius, and in the scientific world, they pretty much use Celsius as well. So, does anybody know this formula for converting? Ethan? It's 5/9 times Fahrenheit. It's actually minus 32. And what do we know about 32 degrees Fahrenheit? Freezing. It's freezing. But what is freezing in Celsius? 0. So you can see that we would subtract 32, which is freezing in Fahrenheit, from the Fahrenheit temperature, and then multiply by 5/9, and you will convert to Celsius. Okay? We have 3 other formulas that you used last year. Simple interest is the first. You remember what that is? I equals, remember? PRT, good. Where principal is P, R is your interest rate, and T is time. And these are all also found in your book. We used that in the spring last year. Okay? We also used the distance formula, which I think is the most commonly used linear equation for real world problems. Remember it? Instead of PERT, we had D equals, D equals, say it, Raquel? RT, dirt. D equals RT. So distance equals the rate you're traveling times time. Keep in mind you could also find time or rate if you knew the other 2 unknowns. You can always manipulate a formula to isolate any part of it. Okay? And finally, the profit. How do you know how much profit a business has made? And profit equals the income it brings in, and what are you going to do with the expenses? If I'm a business and I take $100 in this hour, have I made 100, or what do I have to do with the expenses? Subtract them. Just subtract them. So it actually looks like pi, P-I-E, but P, the profit equals income, and then subtract your expenses. So we could go through a series of real-world problems, but I have put them on your assignment, and we have a large time right now, over 30 minutes to work on this, so I'm going to let you get into your assignment and go ahead and ask questions as you have them. So your assignment is here for both sections, and you may begin.